Hey guys, Zach here. Today I'm going to be talking about context engineering and something that we all probably had a lot of experience with, right? Let me kind of paint the scenario for you. We've all probably been working with an agent and things have gone really, really well, right? You're crushing it. You're asking the agent to do things. It's going and doing things in this kind of like magical way that's pretty impressive. And then all of a sudden, the agent goes rogue. It starts forgetting things. It's doing things that you never even told it to do. And it's this big WTF moment, right? I think we've all been there. We've probably all been in the state where we want to throw our computer out the window and say, screw this. I'm moving on. Agents are overhyped. I want to take a video to kind of address how I solved that, right? And it's not fully solved. I'm still learning new things, but a lot of the things that I'm going to be showing this video can drastically help you guys, especially from what I've seen online. And I think a lot of us have been, aware of prompt engineering and the value of thinking about your prompts and how you ask agents to do things. But this new field, which isn't really that new, but it's new to a lot of people, is context engineering. Context engineering is how we solve that problem with agents being unreliable. And yeah, it takes a lot of work. It's requires some expertise, but just like with anything else, the more you learn about it, the more that you practice it, the more you're going to get better at it, right? So I just want to share some things that I've learned, share some resources. I'm actually going to link a GitHub repo where I've actually put some Claude code, commands and subagents together for you guys so that you guys can get started and use Claude code in a similar way that I do and hopefully learn some things and then get some value out of using agents. So let's go and get started. So the most logical place to start off is probably like, what is context engineering, right? Let's go ahead and define it. I think we've all heard this in the past, and it's something that I even did, so don't feel bad if you're doing this right now, is like you got to feed as much context into the agent as possible, right? Foreshadowing, don't do that. That's a horrible piece of advice. It's going to kill your performance. But jokes aside, context engineering is about how can you find the most relevant information-dense information to feed your agent so that it can do the job that you're asking it to do in the way that you're expecting it to do it, right? So it's about finding the most concise, highly relevant dense information and not bloating it with a bunch of, bad context or context that might confuse it. Just like as a person, you wouldn't eat, a bunch of junk food or eat McDonald's every day or eat 100 Twinkies. We don't want our agent to be fed a bunch of Twinkies, right? We want to feed it high quality food or high quality context. We want to feed it, proteins or vegetables or things that's going to help it do its job better. Context engineering, there's a lot of, it's a kind of a new field. So there's a lot of new techniques, a lot of new best practices coming online. I've kind of added a few here to articulate, kind of give it some examples of, what is context engineering and some of the principles around it. High level, like I said, it's about curating that information and not just letting the context build passively, right? We're managing that now. We're engineering things to make sure that the context is highly relevant, highly concise, highly information dense, right? And some of those techniques that, I'm going to outline here are things like filtering. So not just giving, the full stack of when I do a build, not just passing all the warnings into the agent, but actually filtering out and just passing the information that I want the agent to see, right? So like in the example of the build, don't pass warnings, only pass errors if there's a compilation error, right? That's a really good example of filtering and how you can save tokens. Another one is summarization or compaction, right? I might go have a bunch of agents go do a bunch of work that I don't want the main agent to do, but I want the main agent to get the main insights back from the sub agents, right? So I'm kind of delegating the lower level work to worker agents, but I want the insights back. I could have the sub agents summarize the key insights from their research and pass that back to the main agent. That would be an example of summarization or compaction. Very, very common design technique. Another one's advanced retrieval. We're starting to see some really cool technologies come out with LLMs and agents becoming more popular. Things like RAG, GraphRag. My favorite right now that I've been playing with that I'd encourage you guys to check out on Google Cloud is called Vertex AI Search. It's basically RAG with LLM layer on top of it. It's really, really cool. But we're able to ask questions on text and not have to search it anymore. Now we're able to use vectors and be able to get like key insights back from the book. And this can be actually use it with an MCP tool to expose like textbooks to ground my agents. So this is an example of advanced retrieval. There's just a lot of new technologies out there that make retrieval a lot more focused and specific, so that we're not doing a bunch of research every time we ask a task. And then context scaffolding, right? How are you designing your sub agents? How are you defining your workflows? Is it one big workflow, or is it like 10 workflows that are orchestrated together, right? Think about how you do that scaffolding in that context, and how you structure the context or the information passed between sub agents, and how you design your sub agents and stuff like that, right? So these are just examples of techniques. There's probably hundreds out there. Like I said, it's changing every day. But I just wanted to expose and calibrate, give a definition of what I think I would define as context engineering, and then give some examples of common design patterns for how context engineering is employed. So just before we get started with the main content, I want to go ahead and call out two individuals that I think are incredibly smart, right? I wouldn't consider myself smart. I just like to expose myself to people that are much smarter than me, that have these really cool foundational kind of thoughts or designs. And then obviously I use them and experiment with them and form my own opinions about them. But everything I'm going to be showing in this presentation or this video is kind of a permutation of these two individuals, right? So I want to call out Dex from Humanlayer. Humanlayer is dedicated to context engineering. In my mind, they are the experts. They're the ones leading the field with context engineering and design patterns. And like, every presentation, I've linked the two presentations that Dex has done for Humanlayer. I think one was at AIE, another one was at Y Combinator Root, which is like a little conference that they do with some videos. Really high quality content. You'll even notice that a lot of my diagrams look like his, because I think he's done a really good job about visualizing context and talking about kind of the main design principles and how we should be kind of thinking about the problem space for which we need context engineering to help us engineer a solution. And then the other one I want to mention is IndyDevDan. IndyDevDan is just like this awesome power user, agentic engineer. He has a lot of really cool ideas on like what's the future of agents and LLMs. And he has a lot of free YouTube videos online on like really powerful ways to use Claude code, right? So some of the things I've learned from him are like output styles and how to use like hooks and stuff like that. So some of the things you might see from the GitHub or some of the presentation. Again, I just wanted to call him out, and him and Dex both out. Please don't just listen to me. Maybe watch me for 5 minutes and then go check these guys out. These guys are the real deal. Super smart guys, and constantly pushing the industry forward. So moving to the next slide, we all know tokens are the main currency for agents and really LLMs, right? Agents powered by LLMs, sorry. The context window, is probably a term that everyone has heard. Maybe some of you haven't really understood what it was. Let's kind of start there. So all LLMs have a maximum amount of tokens that they can work in with at any given point in time, right? Think of it kind of as this like finite resource that is the total amount of like working memory that the agent can use, right? So some models go up to like 200,000. A lot of models actually have a cap around 200,000 tokens. Some go all the way up to like 1 million tokens, right? Gemini 2.5, they advertise it for, that was like a big breakthrough of like, hey, huge context window, 1 million tokens, right? But just think of it as like this finite, like total amount of like tokens or context that we can feed into an agent, right? And you can see that on this diagram here. It's kind of like the maximum box that we have driven here, right? The top and the bottom is like this container for how much stuff we can put into the agent or the LLM. And you can see there's a few different boxes here. Obviously, these are going to be different types of tokens, right? So, we're going to have some things like the system prompt or infrastructure. We're going to have like our prompts, like, hey, agent, I want you to go do X, Y, Z. That's the example of a user prompt. And then we're going to have like context or tokens where the agent's actually doing things, right? Like, hey, I read a file. That file was like 500 lines, which is X amount of tokens, right? So some of the things that are filling up the context window are some combination of prompts, infrastructure, and work that the agent's actually doing. So now let's move to like a more realistic example of how people work with agents, right? We kind of looked at this like generic, like what is the context window? Let's move to like a real world example. And I would say this is kind of like the most common way people use agents when they first start out. And that's really this thing where they like continue to ask questions of the agent rather than like spin up a new session every time, right? So if you look at this diagram, you can see kind of the similar thing. We have this context window, which is like the overall container, right? It's like the maximum amount of things that we can feed into the agent. And the colors are the same, right? So the gray is like the infrastructure. To get a little more granular, let's talk about like what's actually in these things, right? So for infrastructure, we have like the system prompt, right? The things that like Anthropic has coded into Claude code to make Claude code to operate the way that it does, right? There's also things like the Claude MD file, MCP tool descriptions, right? These are all things that I would classify as infrastructure, but they do take up tokens in the context window. So they eat up some of your context window, which is a common reason why you don't want like 100 MCP tools in your context. We have user prompts. So again, the green, and then you have like the purple or pinkish boxes, which are, again, the agent actually doing work, right? Like reading files, editing files, doing web search, things like that. So the reason I say this is like the most common way that people use agents is they don't think about managing context, right? They don't think about, how their earlier prompts influence the performance of their most recent prompts, right? So looking at this example, you can see, we start off the agent, it loads up the infrastructure context, the system instructions, the Claude MCP tools, things like that. And then maybe a user says, hey, I want you to go do something. So, ask the agent to do something first. We'll call it ask one, right? That agent might go do some work, right? Do a task, do another task, do another task, right? Let's just say it does 3 tasks and then the work is technically complete. Instead of starting a new session, most people will go ahead and ask the agent to do the next thing, right? So instead of starting a new session, they'll just ask a new prompt in that same session. And as you can see, now all of that context from the earlier prompt and the earlier work is still in that context window, right? And this can lead to a whole bunch of issues, right? We'll get into one with loss in the middle and why this isn't good from just a context utilization point of view. But this also can introduce things like confusion, right? What if you, in your first prompt, ask it to write some code, and then the agent came back and said, yep, everything is perfectly designed. All the code works perfectly. And then you ask it to review its code. When it reviews, it's going to look at the context where it said the code was perfect. Well, when it does a review, it's going to pull that context in. And again, these are using tokens. What do you think that review is going to do? It's probably going to come back kind of superficial, right? It's probably not going to do a really good review because it's being poisoned by earlier context. That context telling it that the code was perfect and now it's reviewing code that it already said was perfect, right? So you can see the issue here. When you're thinking about using agents in context matters, and you don't want to use agents in this way. For this example, you would want to use your first prompt, do that work, let the agent finish its work, and then when it's done, probably start a new session, do / clear, start a new session or a new isolated context window for that second prompt. That way, everything from the earlier work is not plaguing the second work, right? And we're going to get into why this is preferred, context isolation is preferred anyways, from a context utilization point of view in this next slide. So in this slide, I'm trying to visualize a very common white paper that came out for a study called Loss in the Middle. And what Loss in the Middle was a research where they wanted to understand, like, what are all the different influences on context with large language models? What's some characteristics and things that we should be mindful of. So they did a bunch of really cool stuff. Definitely Google Lost in the Middle. I'll probably post a link to it so you guys can find it very easily, but definitely read it. It's really, really informational. But one of the really cool things that they did was kind of this needle in the haystack test where they basically put a piece of text in varying locations of a document. So they tried it at the start of the document. They changed different line numbers until like they tested the end of the document as well, right? So they're trying to test like, does position matter when you're reading context? Does an agent treat the whole the range of that context the same, right? And the results were very surprising, right? This actually what actually named the entire study as Lost in the Middle. What they found was when that context was at the start of the document, or like the question, the location for the answer for the question was at the start of the context or the start of the document, the agent did a pretty good job of remembering, what the answer was. What they found is when they moved it to the end, same kind of thing. Maybe not doesn't remember as much, but still remembers most of the time, where that location was. But what they found, which was the really key insight, is when that context is in the middle someplace, so like in the middle of the document, the agent often forgets, or it's unreliable in the type of answers that it does, right? So like the really interesting thing from this, and this is kind of why you see Anthropic's mention like in the Claude MD file, put like the most important instructions at the top of the file. Well, this is exactly why they're telling you to do this. The start of the context window, so like the first things that you tell it and the last things that you tell it, the agent's going to reliably remember. Everything in the middle is kind of up to chance if the agent remembers it or not, right? So let's look at the next slide to see like what this actually looks like in terms of the context visualizations that we've been using. So again, we have kind of our context window here, right? And again, we have the same example that we used before. So 2 different prompts and, some tasks in between them and things like that. But now you can see there's this kind of blacked out box. This blacked out box represents the lost context that is now in the middle of our context window, right? So you can imagine in this second prompt, if in the earlier prompt, we maybe told it, hey, I want you to do your work and then give me a summary. And in the summary, output it as JSON. You can imagine that was like the end of the first prompt. Well, now when it's doing this work, it might start returning things not in JSON, right? Maybe it's doing XML or something. The likely reason this is happening, if it was working before and now it's no longer working, and we didn't give it any other prompts of like different output formats or anything that would confuse it, is it's probably this loss in the middle behavior, right? This kind of drives us to a really unique optimization, right? To get more reliability and to reduce this loss in the middle effect, we want to basically utilize less context so that loss in the middle is smaller, right? The more the context fills up the context window, the more the middle, like the larger the middle is, right? Like the more context in that middle section, the smaller we use, it scales, right? So that middle section is much smaller. So it's instead of it being like 100 lines that of context it's forgetting, maybe it's only like 1 line of context that it's forgetting, right? To get more reliable agents and to get more performance out of agents, and really what context engineering is all about, it's really about utilizing less of the context window, right? Aaron from HighByte said this really good in the MCP seminar. It was a really good way to do it. To scale up, agents have to scale down, right? We need agents to do very specific things, almost like a micro agent, like kind of like you can think of like a microservice, but instead of it being a service, it could be an agent, like having an agent do one specific thing and one specific thing only. This is kind of the key or like the magic sauce for getting reliable agents. And everything I'm going to show you in the next slides is how you can actually implement this in Claude Code and use things like subagents and commands to do this. But this loss in the middle concept, like bake this in your head. This is such an important principle because it's the majority of users that are struggling with performance, that are finding agents becoming super unreliable, it's because of this loss of middle. They're using too much of the context window. They're utilizing the full context window, and they're not. The agents are forgetting things, right? When I use agents, I typically shoot for like 50 to 60,000 or 50 to 60% utilization of the context window. So like Claude Code, right, is Anthropic, usually like Sonnet, 4.5. I know 4.0 was 200K. I'm not sure what 4.5 is. I haven't checked it in a while, but I think it's somewhere around 200K. Typically, I was shooting for like 80 to 120,000 tokens. If I found myself doing tasks that were consistently going over 120,000 tokens, as a agentic engineer, that is my key indicator of like, hey, I need to break this task. This task is too token intensive. I need to break this up into smaller tasks that can be orchestrated together, right? So that utilization of the context one is really, really important. And again, loss in the middle, super important principle. Bake it into your head. It's going to be used for everything that we're going to talk about going forward. So now we're going to get into sub-agents and really the idea of isolated context windows, right? And being able to delegate, these tasks to reduce the total amount of token utilization or context utilization by our main agent, right? To do this, I want to use a real-world example. Most of us are using Claude Code to develop code. So let's use a real-world example of this. On this diagram, this is kind of like a prompt and some examples of where context engineering could be helpful for here. So this is a single agent, and we're going to look at the multi-agent on the next slide. But let's assume for our user prompt, we ask it to implement a feature into an existing code base, right? So this isn't a new project. We're not asking it to build everything from scratch. There's an existing code base, and we want to add a new feature into this code base, right? Well, one of the first things that the agent is going to need to do is understand the code base, right? Can't just add a new feature and just like insert it, right? It's got to know what the code base and where does it need to refactor things, or what files does it make sense to add this new feature in, things like that. Do we maybe need to add new files? So one of the first thing it's going to do is list all the files and then go through each file and read them, right? So, you can see this section here that denotes like kind of this range of what the agent's doing is finding the relevant code, right? It needs to find what code and what the code is and to understand that code. You can see in this example, it's reading 3 different files or, in many files. What happens if it reads a file that's not relevant, right? Well, if it reads a file that's not relevant, we just wasted a bunch of tokens, right? The main agent, if it's going to implement a change, meaning it's going to actually write code, we don't need to read code that's not relevant, right? We want to keep as much context open so that it has enough context headroom to do the actual edit and to do debugging and things like that, more than we want it to like just read files that aren't relevant, right? So this is a huge waste of tokens, is letting the main agent not only implement the code, but also try to find the code and understand the code base and stuff like that. This is something that we want to delegate out, right? We want to just know what files are relevant. We don't care about the irrelevant ones, right? We want to know what is relevant to the feature being asked here. You can see this middle section, the edit, is actually where the agent's actually doing work. For the main agent, since we're prompting it to do the work, this is probably something we won't delegate out. We'll want this agent to do this work out. So that's probably something that you'll see, in the next slide as well. But here's another example of where context engineering, that filtering is what we talked about earlier, right? So imagine after the edit or after the agent has added the feature in, it goes and does like a .NET build. Maybe it just does like a quick, check to make sure the code can compile. Let's say for some reason this is like a huge code base and there's 800 warnings. Why you would have 800 warnings, I don't know. Maybe that team needs SonarQube or something to help them, manage that. But let's just, for argument's sake, say there's a huge amount of warnings that we don't care about, right? You can see in the example, there's 0 errors. So the build compile, there was no compile errors from this or anything like that. Well, all 800 warnings just got read into the context window of our agent. if remember from the loss in the middle principle, we want to try to reduce the utilization of our context window. We don't want to be bloating it with context that like we don't care about, things like warnings or things like that that aren't relevant for the task, right? So this is an example where context engineering could really help and preserve context and reduce the total amount of context bloat by maybe adding some type of long running tool, maybe adding like an MCP tool that does the build and our agent just calls a tool and we get either a success, or if there are errors, compilation errors, it just returns the error and maybe like the, what you would see in the error window of like Visual Studio, right? We don't like all these warnings and things that like don't add context, right? So hopefully you can start to understand where there's some opportunities for us to do some context engineering and to save context and get better performance out of our main agent who's doing the edit, but still do the relevant things to, find the relevant files that need to be edited, to do the builds and things like that. So let's look at that at the next slide. We actually have an example of what that would look like. So here is the exact same like process or use case, but what it would look like maybe using a multi-agent, some of those context engineering principles that we had talked about, right? So here is that example we saw in the first slide with just like using a single agent to do like the research and the edit and the build with like all the warnings that we don't care about. And then on the right-hand side here, this is what it would look like if we were to use some like context engineering best practices, right? So remember, like the majority of this context window was used by doing the research, right? For the agent to understand what files are in the project, what files are relevant for the feature that we want, right? We wasted a lot of context in the single agent because it had to read a lot of files that weren't relevant, right? What if we used a sub agent or an isolated context window that's isolated from our main agent, who again, main responsibility is to do the edit? What if we use a sub agent to do the research, right? So that's what this diagram on the right is, right? We still have the same user prompt. Hey, I want you to go in and do like this new feature, XYZ, this some PRD or whatever, like basically just a prompt of like what you want it to do. What if the main agent now invokes a sub agent to go do all the research, right? So now the sub agent spawns, which is this other context window. This context window is totally isolated from the main agent. The main agent's going to give it a prompt like, hey, sub agent, I want you to go find the relevant files for this feature that the user asked me to implement, right? Well, now this sub agent is going to use its context window, which again is isolated from our main agent, to do all the relevant file searching and file reads and stuff like that. And what will return is the sub agent will respond to the main agent after it's done all its work with only the relevant files that the main agent needs to know about, right? So we just saved the main agent tons of context, right? It didn't read a bunch of files that aren't relevant. It didn't read like all of the files or anything like that. Basically just delegated that work to a sub agent. The sub agent used all of its context window, which is okay. We want to leverage like the more tokens we can consume, the faster we can do work generally. But now the main agent only gets back a concise, highly relevant information of context, which is the relevant files that it needs to edit, right? So again, context engineering, actively managing the context, making sure that we're curating the context, not just feeding it as much information as possible. This is a really good example of how sub-agents can be used. And then, coming back, the main agent's going to see, okay, hey, I have these two relevant files. It might still do a read, but only on those two files, right? Not on all these other files that it doesn't care about or aren't relevant for our feature update. It will go do the edit, right? So again, we can't really save work there. You might delegate that out if you just want your main agent to do orchestration. For keeping it simple, let's just say the main agent is actually doing the edit. So it's not, there's really nothing that's different here. But then remember when we did the build at the end of the edit, we returned all the errors before we use like a long running task or an MCP tool to do like the build to filter out some of the context to the main agent. What if we had an MCP tool to do that, right? So the main agent can do like a build tool call that behind the scenes does like .NET build, but maybe there's some logic in there that filters out information that we don't want to return the agent, and it only returns like success or error, and then like the compilation error, right? Well, now we just saved a bunch more context, right? Instead of feeding it the 800 warnings that the main agent would normally have seen in the other case, now it's only seeing success, right? Instead of the 800 warnings, right? So what this means is, if you look at this diagram, the exact same process, doing the exact same tasks, actually even copied all these boxes over, the main agent is able to use roughly 50% of the context that it did compared to the first case, right? Again, what this means is the main agent will be more performant, it'll be more reliable, and it'll do things in a more consistent manner because, again, that man in the middle, we're not exposing the main agent to like context poisoning or context from another source that conflicts with the context in its main context window, right? This is an example of what good context engineering looks like, and hopefully starts to give you ideas of the value of isolated context windows, how you can use long-running tool calls to do filtering and things like that, and how you might start thinking about both task decomposition. So how can I start decomposing really complex tasks into smaller tasks? And then also like what the design of my sub-agents, right? Like, don't design sub-agents to like assume a role, right? Use sub-agents as a tool to manage context, right? Dex said that in one of his presentations. It's so accurate. I think the natural, temptation is like to go play house, is what Dex said. It seems intuitive, doesn't work. Use them as a tool. Large language models, agents, deterministic code, MCP, they're all code. Let's treat them like code. Let's do the things that we have like around engineering best practices and use them in ways that they can, get real work done for us, right? Use them as a tool. Don't use them as a role. So kind of taking this idea of sub-agents, let's take it even one step further, right? I've used sub-agents on greenfield projects, small projects that I've done, like side hustle stuff with just, a few thousand lines of code. And then I've actually used sub-agents, and I have some Claude Code agentics for like code bases that are like 300,000, 500,000 lines of code, right? And what you will find is the amount of task decomposition you do will start to change as you start working on larger projects, right? When you're working on a project with 400,000 lines of code, you probably aren't going to be able to just use one sub-agent to do all the research, right? Even with just one sub-agent, it's going to fill up the context window. You have to start decomposing that task into many levels down, depending on what you're asking the agent to do and things like that. That's that whole scaffolding that I talked about on the first slide. Agentics, agentic engineering, that's really what they do, right? They think about workflows. They think about decomposition. They think about abstraction, right? There's this idea of like higher level prompts and lower level prompts, right? Your higher level prompt might be do like something like plan, research, evaluate, and then like you might have a lower level prompt that says like, for this type of feature, this is the plan, right? So like there's a lot that goes into that, but start thinking about how can you decompose tasks? How can you break them into smaller tasks that a single agent or multi-agents could do like more reliably, and then orchestrate them in a way that allows you to do very complex things, but with really many small micro agents working together, rather than like trying to have one agent do it all, right? Which is just not going to work, right? That's like, to me, I get so frustrated when people like say LLMs or agents don't work. And the reason why is they have like a really low barrier to entry. It's really easy to like prompt an agent to like, read a markdown, right? Like anyone can do that. Once you start having it do things that can't reliably fit into a single context window, it's usually when people start running into issues. People typically don't invest the time to like do like engineering work. They like want the easy approach, so they start blaming the model. These are the things that we need to be developing best practices on, right? These are the engineering principles that we've always done in deterministic code that we need to start thinking about for probabilistic code or things like agents, things like LLMs. And specifically how we fuse those things together, right? How do LLMs and deterministic code work together, right? So again, kind of a long rant. Just wanted to kind of get that out there. To me, engineering is a big part of everything that we do. No different from LLMs and agent design. Start thinking about your workflow. Start thinking about subagents. Start thinking about task decomposition and context engineering. I wanted to show an example of like that very complex example for like what you might have to do for really large projects. I like to even break out research tasks into specific things that the subagents are looking for in the research, right? So for example, let's say the user said, hey, help me explain this code to me. The main agent might spin up a subagent to find what files are relevant. That subagent might return a summary of file 1, 2, and 3 are relevant, ignore 4, 5, 6 or whatever. The main agent might spin up, instead of like a subagent to read those files, maybe it spins up like subagents to look for one specific thing, right? So like out of those files, subagent 2 looks at only dependencies, right? Subagent 3 looks at only the main flows through those files, right? Like what are the major data flows through that logic, right? Or that business logic. And then subagent 4 might look at the contracts or the DTOs between the components, right? When we pass code from component 1 to component 2, like what's the DTO, what's the signature, the function calls, things like that. You might need to start decomposing instead of just doing research. You might need to decompose like what is research, right? So it's understanding the flows, it's understanding dependencies, right? You might even get down to like even a level below this, right? So again, don't use this as an example of like go implement this. Like don't go implement a research DTO subagent. Think about what does it mean to decompose tasks, and then like what are the underlying tasks that need to get completed for like a higher level task, right? So for research, what are the questions that we need subagents to go do to be able to do research, right? So again, kind of this one's maybe a little bit of stress for a lot of you. This is kind of getting into this like layer of abstraction of how we use subagents and task decomposition, but very, very important. Hopefully you start to understand isolated context windows. You want to shield the main agent from, the work that it doesn't need, and like from doing the work that it doesn't need to do and saving it context that it doesn't need to load. We want subagents to go do the work and return just the insights, right? So again, subagents. So last slide, and then we're actually going to get into the GitHub repo. Not the GitHub repo. I'm just going to give you a link to the GitHub repo, but I am going to show you guys Claude Code and kind of how the commands are used, just for some of you might not know how the commands are used. But this is a very fundamental but staple workflow for most development cycles right now, using multi-agents, using something like Claude Code, using something like commands, right? The GitHub repo, you'll see the commands and the subagents and things like this. This is kind of like the pattern that they follow. But there's 3 different distinct phases, right? There's a research phase, or a, hey, go understand the code base, understand what files are relevant. There's a planning phase. Hey, I want you to go do something. Tell me how you're going to do it before you do it, so that if there's a mistake that the agent like is thinking about implementing, I can catch it before it implements it. And then there's an actual implementation phase, right? And for each of these phases, there's going to be clear prompts. There's going to be subagents that are used within that phase to, again, do that task decomposition, to isolate the main agent from doing its work. One of the important things, Dex talks about this so accurate, is especially when you're talking about in-loop and out-loop design patterns, is where there are human gates, you have to be reviewing, right? Dex, I'll link Dex's slide to this. Such a good point. He talks about this idea of like compounding effects and like catching things early versus like trying to fix things late in the process. And I think the example that he uses is like a line of code, right? A bad line of code that an agent writes is just one bad line of code, right? It's kind of like the atomic unit of measure, I guess, for agent correctness, I guess, is how Dex is using it. But it's a good example, so let me explain it. A bad plan could be hundreds of lines of bad code. So one bad line in the plan could be hundreds of lines of bad code, right? And then one bad line of research could be 10 bad lines in the plan, which could be thousands of bad lines in the code, right? So you have this compounding effects. It's really important that you do the human reviews, that after research, you're actually researching, making sure that the agent documented the actual code base, that there is alignment there. Planning, Dex has a really good statement about this. Code reviews, they're less about reviewing the code. I mean, sometimes they are like styling and convention and stuff like that, but they're more about mental alignment, right? Meaning like, hey, when a developer implements a feature, we're making sure that that developer is doing things in a logical way, is doing things in alignment with the architecture. There is some mental alignment that is happening within a design code review. That's what essentially planning is, right? It's our opportunity to catch when the agent has gone off the rails or didn't do something the way that we wanted it to do, or there's some misalignment. That is our opportunity for us to fix those things before they get implemented into the actual code base and become real nightmares for us to handle, right? So again, these human reviews really important. You have to review them. Don't automate them out. In loop is awesome because we don't have to touch it. Agents go and orchestrate amongst themselves. But when we get called in that out loop to review the in loop, you got to review it. You can't just ignore it. You got to do the work. And that's what these human reviews are. And you'll see that in the GitHub and the examples that I show you. But okay, enough theory. I am tired of talking. Let's get into the actual example of Claude Code and actually play around with the fun stuff. All right, guys, and now to the fun stuff. I promise I am almost done talking and you guys can kind of get started and start playing with some of the things I've created for you guys. In the YouTube video and on LinkedIn, I'll post a link to the GitHub repo where I've uploaded all these things. I've uploaded a few different Claude resources, such as subagents and some commands to get you started with the concepts that we have talked about. Some of them are taking from Humanlayer, some other sources, and some of them I've kind of modified and developed myself. And then I've also uploaded a dummy project. It's just a C# web server, basically an API that you can kind of test things on and kind of test the Claude Code agents that I've created for you guys, just to kind of get some awareness instead of having to create a new project just to test something out. So I'll post a link on the GitHub, but I'm already sharing my screen. So let me kind of just walk you guys through for some of you that might not be as familiar with Claude Code, right? So I'm in Visual Studio Code. My home environment, I actually have an enterprise server that I have a bunch of Linux VMs run on. So I actually use a Linux VM for all my development. I'm actually going to use an SSH on Visual Studio, which is what you see in the terminal right now. I'm going to go ahead and launch a Claude instance. So I just do Claude YOLO. Your Claude CLI commands won't look like that. I've done some customization. YOLO mode is the permission mode to allow the agent to do edits without prompting me for permissions every time. Let me talk about the file structure that you're going to see here, right? So when you clone this repo, you're going to have a few folders. One is Claude. This is the directory that Claude normally would create, and agents is the subdirectory that Claude would create to create subagents in. And then same with command. Commands is where Claude normally creates commands if you were to do it through the CLI. Here you'll see that I've already created some subagents for you guys, things like the code base locator, pattern finder, and then also some commands here. And we'll kind of talk through the commands. You can see they're pretty much numbered except for the git commit. Git commit's not ordered because you probably just run that command whenever you want. But there are a workflow here that you'll follow: the ticket, the research, the plan, the execute, the verify. Right, the things that we had talked about before, those major phases that you're going to want to do a human review on. Then there's docs folder, which is just where I've gone ahead and uploaded my PDF for the slides that I shared on the video, just in case you guys want access to those slides, want to look at them in more detail or share them with others. I've gone ahead and uploaded them there so you guys can have access to them. Source is where that C# project's at. I've included a README in there as well. to kind of give you some understanding of what's in there. It's a very, very light, very, very small application. It's really not to demonstrate how complex or large of a project Claude Code can work with. It's really just to provide a project that you guys can, clone and immediately test the agents and the workflows without having to create like a new project from scratch, right? It's just kind of like a dummy project for you guys to use and for me to demo for this. And then there's the README, which kind of details some of the things that we talked about. It's going to contain some of the links to some of the other contributors and things that I've talked about, and things like that. One thing I want to talk about is thoughts. So in the commands that I created, and we use thoughts is kind of where we store like AI documentation or like plans or tickets or research or things like that. So as the agents create things, they're actually going to use the thoughts directory to put research or plans or tickets or reviews and things like that. So you'll notice there's thoughts there. There's a README that it kind of explains what the thoughts directory structure looks like, but just know that's what the thoughts is. It's the location that the agents are going to use to upload files and things like that, right? So once you're in Claude Code, if you've never used a Claude Code command, just think of Claude Code commands as a way to codify the prompts. If we always want to be thinking about, from an agentic engineer, we always want to be thinking about how can we improve our velocity or scale our workflows. Anytime you're running a prompt and you find yourself running it more than once, you should be creating a command for that. And then commands can actually be used by agents. Agents can actually invoke commands, which is really cool. But in Claude Code, you just do a /, and that's going to bring up context of what commands are loaded in there, right? So all of my commands are prefixed with my initials. And then the prefix is supposed to be the number that you see there is like the order, right? So the first one you would normally run is ticket. And you can see in the command, I actually added some metadata to the format, the front matter, to essentially provide some kind of insights for you guys, right? So the ticket is to create a structured ticket for bugs, features, and technical debt based on user input, extracts keywords. So just some kind of context to help you guys understand like what are these things for, right? But I type in the command, you're going to see there's like hints to tell me what is the input that I'm going to pass into the command. So commands are kind of like functions. They're prompts, but you can inject arguments into them, which is really powerful, right? So here it's asking me for the solution. So our solution is the agentic demo.sln. And then the second one would just be the prompt that I'm asking it. The ticket process is a progressive disclosure like questionnaire for the agent to understand and make sure the requirements are already understood. I'm not going to run that command because I don't think you guys want me to answer a bunch of questions. I've went ahead and created a ticket and followed that through earlier. And this is the output of that ticket. So this is actually what the sub agent created during the ticket process for the request that I gave it, right? It went ahead and make sure I did some tags, some keywords, some patterns. These are metadata that agents are going to be able to do string searches on later and define it as a bug, and then some requirements for things that I expect in terms of how the new behavior or the new feature should work. And then some different kind of criteria, right? So this is kind of like a high level ticket that you would expect through like something like Jira or Asana or Linear, anything that you would normally be getting your tasking and describe like acceptance criteria and what the ask is. The agent created this, which will be context later down the pipe, right? So we're actually going to skip the ticket phase because I actually want you guys to see sub-agents in action and how they are used. So what we're going to go ahead and do is go into the next phase, right? So the next command I would normally run is the research phase, right? And remember, research is for the agents to understand the code base and, what code files are relevant, things like that. And it's going to use sub-agents to use this to not bloat the main context of the main agent who should be doing the edits themselves, right? So again, it's telling me, what the inputs to this are, which are, and I can't type. And then it's asking me for the location of our ticket, right? We're passing the ticket in as context into our research phase. So the output of the last agent from the last major phase in as an input into this phase so the agent can load it as context. Remember, context, curating, high signal, low noise, highly relevant, information dense context, right? That's what we're trying to do. So I'm going to just pass it the context of thoughts, tickets, and you can see it's set right here. And I'm going to go ahead and hit search or hit enter. So you can see when I entered that, it's saying the command is running. It added that is running prefix. So I know that the command was seen by Claude Code, and Claude Code is treating it as command. You can see it's gone ahead and actually created the to-do right with the detailed orchestration steps that I have defined in that research command, right? So it's saying, hey, I'm reading the ticket, load the ticket from the file. So it went ahead and read the ticket and looked at all the context, and it can see that there are some research areas that it needs to do, right? So the next phase is to launch some sub-agents to look through our thoughts. Remember, that's like our tickets or research metadata that users might have created or other agents to get more context, right? So it's spun up a thoughts locator that's looking for task management thoughts, and one that's looking for any bugs or issues that have previously been reported, right? And again, these are sub-agents being invoked here. So the main agent, even though these files are being read and, tokens are being spent, this is not context that the main agent is going to be seeing, right? This is context that is isolated from the main agent. These sub-agents will respond with a synthesized response back to the main agent, so the main agent understands that, right? So you can see these sub-agents use about 8,000 tokens. So 16,000 tokens in total is what we saved our main agent so far. So let's kind of watch this just a little bit longer. I'm not going to go through the full workflow and show you guys every step, but you can see the next phase is that it's going to go ahead and look for files for different various things, right? It's going to look for the code base for the task model. It's going to look for the code base for our API inputs. It's going to look for our code base for entity framework implementation or DTOs and mapping, right? So again, we're using sub-agents to isolate the main agent, let these sub-agents go do work. We're delegating the work to sub-agents, and the sub-agents will only return back to the main agent what files are relevant, right? So this is, again, an example of how sub-agents and context engineering can really come into play, really save performance on the main agent and allow you to scale out the complexity of things that you're working on, right? Again, remember, with agents, the smaller and lower utilization we can get on the context window for the agent, the more performant and more reliable that agent's going to be. So yeah, I'm just going to go ahead and let this run. Let me go ahead. Actually, I'm not going to let this run. I'm going to go ahead and exit this out. You can see those agents would have continued and completed their work. Let me just talk about the commands real quick. Again, ticket is to create the task, essentially. It's like what you would get through Jira. Research is to look through the code base. Then you're going to go into a plan phase. Plan would be to for the agents to show you what they plan to do so that you can get that mental alignment that we talked about before. 4 is to execute, so that's actually the implementation phase. And then 5 is to verify. So with agents, it's really important to always validate the work that they're doing or verify the work that they're doing. And you always want to do the validation on another context, isolated context window from the main implementation agent. Again, that example I used earlier, don't ask an agent to write code. The agent say, hey, the code is perfect, and then ask it to validate. It will always come back and say, oh yeah, everything's good. Because again, that context poisoning has happened from earlier steps, right? Always spin up an isolated context window, ask it to validate on a new context session. And then the last one is, the git commit. So I haven't shown the git commit. Git commit is not a workflow command. It's just a command that, again, I've codified because it's one that you run all the time. If I look at the git commit, you can see it actually is a way for us to basically have agents commit things and use a standard format for naming convention and the types of things that we want it to commit and things like that. So I added that one in just because like you're always going to want to have git commits, right? So I just added that one in. But again, just look at these commands, look at these agents, look at the ways that I've structured these agents and commands. Most of these are coming from Humanlayer and other people that have done agent work. I've kind of expanded on those and added some of my own things, but there's a lot of common practices, best practices being used here. But just really read through them and play with them. And then if you guys have any questions, if you like this content, let me know in the comments. Let me know what's confusing or if this is too much information in one go. Any interaction is really good for me. Like I said in an earlier LinkedIn post, I want to do more of this kind of content. I want to know what's valuable for you guys. Is this too much theory? Do you want to see more of the video on hand stuff? Let me know, and I'm going to try to start consistently posting something every week. So I hope you guys enjoyed it. Share if you guys did, and I hope to catch you guys again later. See ya. Bye.